In this video for section 4.1, we're going to talk about exponential functions. Exponential functions are functions where the variable x is in the exponent. So if we have an exponential function, f with base b, f of x equals b to the x power, or y equals b to the x power. The base b must be a positive constant other than 1. So some examples of exponential functions: f of x equals 2 to the x, has a base of 2. G of x equals 10 to the x, has a base of 10. H of x equals 3 to the x plus 1, which has a base of 3. So the exponent could have things added or subtracted or multiplied by the variable. It doesn't just have to be the variable by itself. And lastly, j of x equals 1/2 to the x minus 1. That has a base of 1/2, so the base could be a whole number or it could be a fraction or a decimal, as long as it's positive and not equal to 1. So at this point, you've probably used this button on your calculator already, but you will need to use a calculator to evaluate exponential expressions in this section. So you'll want to find either the y to the x key or the caret key and use that in order to evaluate exponents. So we're going to look at example 1 from the textbook. It says the exponential function f of x equals 42.2 times 1.56 to the x power. Models the average amount spent, f of x, in dollars at a shopping mall after x hours. What is the average amount spent to the nearest dollar after 4 hours? So what we're going to do here, since we want to find the amount spent after 4 hours, and x is the number of hours spent at the mall, we're going to plug 4 in for x. So we're going to calculate f of 4. Remember that f is dollar amount. So this is going to be 42.2 times 1.56 to the 4th. Now, what I would recommend doing, if you have a calculator that you can just type this all in all at once, that's usually the best way to make sure that you don't get a mistake in rounding. Or, if you don't have that kind of calculator, I would recommend using the calculator at decimals.com. If you're trying to use a calculator such as an iPhone calculator, where you can only do one operation at a time, then you will need to make sure that you do the correct order of operations yourself. So I'm going to show you how to do that. So you need to remember that exponents comes before multiplying. So I can't multiply 42.2 times 1.56 first. I have to do 1.56 to the 4th power first, and then multiply the answer by 42.2. So 1.56 to the 4th power. I'm going to round to 3 digits after the decimal point. Generally speaking, you want to try to keep a lot of digits out here, because if you round too early, then you might be off in terms of rounding, and that might cause you to get the wrong answer. So usually 3 to 4 digits is pretty safe. So I'm going to multiply 42.2 times 5.922, or if I just typed this all into my calculator at once, what I would get would be 249.93. $249.93. Now, one thing that you always want to look for in these problems is the instructions that tell you how to round. In this problem, it's telling me to round to the nearest dollar. So I would round this to $250. If you don't round the way the problem asks you, then it's going to be marked wrong. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer, and then move on with the video. Next, we're going to talk about graphing exponential functions. So we want to graph f of x equals 2 to the x. And remember, when you're dealing with functions and graphing, the f of x can be replaced with y. So f of x is the y coordinate. Now, we're going to walk through this in the way that it looks in the homework, which is that they're going to have a table of values for you to calculate first. So the values that they're going to give you to plug in for x are -2, -1, 0, 1, and 2. And it's going to tell you in the instructions to enter your answers as whole numbers or fractions, not decimals. So When you're doing, for example, this first one is 2 to the negative 2. Now 2 to the negative 2, if I use my rule of exponents, that's going to be 1 over 2 to the positive 2, which is 1/4. If I try to type 0.25 in here, then MyLab Math is going to mark it incorrect. They want the answer written as a fraction. 2 to the negative 1 is 1 over 2 to the positive 1, which is 1/2. So 1/2 go in here. If you have a calculator that can give you answers as fractions, you can use that. Otherwise, you're going to need to think about writing it as 1 over the base to the exponent when the exponent becomes positive, and then you can do that math there. So 2 to the 0 power is 1. Anything to the 0 power is 1. 2 to the first is 2, and 2 squared is 4. So in terms of the graph, what it's going to look like, we have negative 2, 1/4, which is going to be just above the x-axis, negative 1, 1/2, so halfway between 0 and 1, 0, 1, 1, 2, and 2, 4. So the shape of this graph sort of looks like a parabola on one side, but the other side is going to be an asymptote, where it doesn't cross the x-axis. So it has an asymptote on the left side and then sharply increasing on the right. In MyLab Math, they actually don't have the ability for you to draw this graph, so you're going to pick from some multiple choice graphs, so that'll make it a little bit easier. So next you should look at checkpoint problem number 2. Do this in your notes, check your answer, and then move on with the video. Lastly, we're going to talk about the natural base e, which is important in many applications of exponential functions. E is approximately 2.718. It's like pi in that it's a non-repeating, never-ending decimal number. Most calculators will have a key for either e or e to the x. They might have both keys, it just depends on the calculator. So you're going to need to find that button on your calculator. So we're going to do example 6 from the textbook next. The exponential function, right here, f of x, models the gray wolf population of the Western Great Lakes, f of x years after 1978. According to the model, what was the gray wolf population rounded to the nearest whole number in 2014? So this is our function. Now this one is a little bit different from example 1 in that we're not just plugging the time in, because x is years after 1978. They want to know the population in 2014. So what I have to do first is figure out how many years that is. So 2014 minus 1978, that will give me that is 36 years. So that means 36 is what I'm going to plug in for x. So f of 36 equals 1145 e. Now, my exponent here is a little bit more complicated as well. 0.0325 times x, which is 36. So if I'm doing this out the long way, what I would need to do is I would need to multiply that in the exponent first. Again, what I recommend doing, if you can, is to just type all of this into your calculator just like this. And that way you will get an answer, like I said, that is going to be the most accurate and not subject to rounding errors. If I multiply 0.0325 times 36, that's 1.17. Then according to order of operations, I would do e to the 1.17 next. And if I do that, that is equal to 3.222. And then lastly, multiplying by 1145 equals 3,689.19. And again, the last thing that I want to check is my rounding. It's telling me to round to the nearest whole number, which makes sense because you can't have a fractional part of a wolf. So rounding to the nearest whole number here would be 3,689. And And again, if you just type this all into your calculator like this, then that's the easiest way to get this answer right away. So next you should look at checkpoint problem number 6. Do this in your notes, check your answer, and then move on to the homework.